In the beginning, there was only time. An endless expanse stretching into infinity, waiting for a spark. Amidst this void, a vision arose, a beacon of ingenuity and passion destined to illuminate the darkness. This was the dawn of an era, the birth of a journey that would transcend boundaries and inspire minds. From the silence emerged a voice, a guide, a helper in the vast circuitry of our digital expanse. This was not just any guide, but the circuit helper, a harbinger of knowledge, unraveling the mysteries of technology.
Whoa, 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 that's a little bit too dramatic. But would you take a look at that? 1,000 subscribers. I can't believe I've actually made it this far, especially when my first few videos got like 10 views. But that doesn't matter. I made it in the end. Super pleased about that. And I have to thank everybody for watching. So I've poured myself a drink, and cheers for watching the videos and liking and subscribing. So cheers. So in this video, I thought we'd do something a little bit more fun and a little bit more involved actually. So for a long time now, I've been wanting to make a coffee bean roasting machine. So I've been buying coffee beans from the shop near my house, £10 for a bag of like 200 grams. That makes like 15, 20 cups. That's quite expensive. So I want to make a roasting machine because you can buy green coffee beans for much, much cheaper than roasted ones. That's the plan, but the reality is quite different. So I burned myself twice.
Ouch.
I blow several fuses and nearly cause a fire. I learn how to use Arduino IoT Cloud, and I nearly poison myself drinking what I roast. So with that, let's make a start. Let's have a look at the plan of what we're actually going to do. So I've bought some components. These are all from Amazon in the UK, and I've listed the prices. So you can see I've got a couple of power supplies. One's a 5-volt one, one's a 24-volt one. I bought an ESP32 that's really going to be the brains of this operation, and a solid-state relay. And also I got a sensor that's a thermocouple module based on a Max 6675 with a K-type thermocouple, and a motor control module that's based on the LN298 chip. So the idea is to integrate all those components into that popcorn maker. So I bought that from Amazon as well, cost about £20, to make it into a coffee bean roaster. And the idea is to make delicious tasting coffee. Whether that's possible or not, who knows? But we're going to give it a go. And it's really actually a learning process, because I'm going to use the Arduino IoT Cloud to basically make a user interface to control all this via the web. I've never used that before, so it's a bit of a learning experience as well. So that's cool. And the end result really is to be able to make coffee as good as that coffee roaster that you can also buy from Amazon at, 3 times the price. So that'd be awesome if we can do that. Let's have a look at a bit more detail now on how this thing's going to get all wired together. So the plan is to take the mains voltage, that's 240 volts AC in the UK, connect them to these 2 power supply modules. So these are sort of isolated small modules that give a low voltage DC output. The ESP32s, the microprocessor that's going to control everything, that can have a 5-volt input or a 3.3 volts, but we're going to use 5 volts. That will interface with the thermocouple module, so that's a 3.3 volts because it's sending data back to the ESP32. You don't really want to put 5 volts on the data pins of the ESP32, so that would be a problem if that was powered by 5 volts. So there we've got to be careful. We can take the 3.3 volts off the ESP32. I'm going to use the ESP32 to trigger the relay, so that's going to be a 3.3 volt signal, and I'm going to use the 5 volts from the ESP as well to control the low voltage part of the motor controller. Obviously the 24 volts is going to be actually driving the motor in the popcorn maker. Here on the right hand side of the screen is really the popcorn maker, basically a DC motor and a heating element. So to control the speed of the DC motor, I'm going to use a pulse width modulation scheme, I'm not going to have any feedback there. It's just going to be set the duty cycle to 50% and I'll get half the speed of the motor. If I set it to 100%, I'm going to get full speed. So to control the heating element, I'm going to use this solid state relay basically to chop up the mains voltage. So if I want, again, it's a pulse width modulation. If I want 50% power, I'm going to have the heating element on 50% of the time. If I want 100% of the power, I'm going to have the heating element on 100% of the time. That's what's going to roast the beans, and I'm going to have my thermocouple also mounted near those beans so I can get a temperature measurement, feed back to the ESP32 so I can dynamically adjust the heating power to make sure the beans don't burn. I'm going to use a PID loop to do that. So let's crack on and have a look at what's going on in the lab as I actually build this thing. So here is basically the guts of a popcorn maker. It's just a cheap, nasty one that I got from Amazon. It was like £15. I was going to show you me taking it apart, but it caused so much moaning, so much complaining that I'm not going to show that on YouTube. So here I've freed the popcorn maker components, the actual heating element and fan, and I'm just removing the circuit board from the back. So there's the motor freed of the actual circuit board. Obviously that's not going to stand up, and that's where my little 3D printed component is going to come in. So hopefully that should just about be too big, and when I stretch it open it will slide in. There you go, rock solid, that's not going anywhere. I'm also going to pop a cable gland through there, I think, so we can get the cables in and out of the box. So, there's two bits to this. This bit's simple, that's the DC motor. Spins round, makes air. Air goes through the heating element, which is this bit here, and out through those vents in there to heat the popcorn or the beans. So we don't really need to touch this bit, that's okay. This bit requires some thinking, so annoyingly I believe there's two different heating elements here. So that's just the metal. Here we've got, I believe, looking online, two sets of heating coils, hence the 3 wires. Trouble is I don't know which one's which. 7.5 ohms, so I believe I've connected those two heating elements in parallel, so they've reduced their combined resistance, so it's like 30 and like 45. I've also been a little bit naughty. I'm not going to get rid of the thermal fuse, but I've just pulled it away so it's less likely to break. I'll try and put this back together. Inside this box I'm going to need all these gubbins. It's going to be tricky. And a solid state relay. It's looking small. So we've got a 24 volt power supply, so it goes mains 240 volts to 24 volts. That's for the DC motor. Wish I'd not bought such a big one. We're going to use an ESP32 to control this. And this is the thermocouple module. The question is, where's all this going to go? So this is the solid state relay. It's pretty big and I haven't got much space, which is a problem. And also, that's really should be on a heatsink, you know, a big block of metal to keep it cool. A plastic lid is not a big block of metal, which is a problem. There's a good chance it might overheat, but there's very little I can do because, well, I don't have a heatsink and I don't have any space, so I'm kind of stuck. So I have to give it some thought, and I think the best place to place the relay is going to be on the lid of the box, something like there maybe. Ideally I could use that screw and another screw here to actually fasten it in place. What else I can do now, other than pray it doesn't set on fire. So I've opened up the Arduino IoT web page. So this is what the dashboard looks like. It looks relatively complicated, but it isn't. The first thing you need to do is make a new thing. So I'm going to call this coffee roaster or something like that. And once I've made that thing, you actually set up your device. So here I'm going to select the ESP32. And this particular board is this Do It Dev Kit. I don't know why it's this one. That's what somebody said in the comments on Amazon when I bought it. So here I'm giving the board a name, Coffee Roaster or Coffee ESP. And then you get some device ID and a secret key. You definitely need to keep these. This allows you to access the device via the internet remotely. It's got this unique device ID. So here you enter your details of your Wi-Fi network, and this all gets uploaded onto the ESP32 and it automatically connects to your network. So that's the board set up. The next thing to do really is to start adding variables. So these variables are pretty cool. They actually, you create them here and they're actually stored on the ESP32 and in the IoT dashboard that we're going to make soon. So here I've got a temperature, I've defined it as a float, and that's going to be the temperature read by my thermocouple module. So I'm going to periodically read that variable. So there's several more variables I need to add. And quite annoyingly, this actual free version of the IoT Cloud is limited to, I think, 5 variables. This is a real shame because I had big plans to make a really nice dashboard, but I wasn't able to do that. So that's a shame. I definitely wanted to have PID, so the control parameters on the dashboard, so I didn't have to reprogram the ESP32 every time I just wanted to try a different setting. I've now got all my variables added to the sort of workspace, cloud variables as they're called. That's the sketch, which I'll talk about later, but here's the actual dashboard that you see when you go on your mobile or when you log on, and you add dials and buttons and charts simply by clicking on the left-hand panel and adding them, and then you link them to those variables you saw me create. So basically, if you add a chart, you can add that temperature variable to it, and whatever the Arduino or ESP32 measures and assigns values to that float of a temperature, that's the value that will appear on that chart. So here I'm doing fan speed, and this is actually an input. So the user is going to put a percentage like 10%, 100%, and that will then be uploaded. I'm not going to go through the code line by line, but basically I've got 2 libraries. That's the PID controller and the MAX6675 thermocouple module. Those are the pins that the thermocouple module is connected to the ESP32. This sets up the thermocouple and the PID controller. These are the cloud variables. So if whatever I do on the ESP32, say I say temp equals 100, then that will appear on the IoT dashboard, which is pretty cool, very useful. This is added by the IoT cloud. This is where my solid state relay is connected, and that's going to be my pulse modulation for the motor, so the fan on the popcorn popper. These are just a few more variables. This sets up the PWM for controlling the speed of the fan. I'm basically pretending it's an LED and using this LED PWM controller. I've set the frequency for 500 Hertz. It's on channel 0, and I'm going to use an 8-bit resolution. So there's going to go between 0 and 255 steps, the duty cycle. Some various other things. I set up some serial for debugging. I entered some just guessed parameters for P, I, and D. So P, I, and D, I don't know if they're right or not, but it was such a pain to have to connect the ESP32 to plug it back into my computer. I didn't really get a chance to play with those parameters at all, and you'll see that later when we're actually roasting the coffee. The PID limits, so basically this means that the output is going to be a number between 0 and 2000. So if we're miles away from the set point, the number is going to be larger, it'll be 2000. And if we're at the set point or above it, the number is going to be 0. And we're going to use that to set our duty cycle of our heating elements. So then there's some more setup for the cloud, and this is the main loop. Basically, we do a temperature read. It sends that value to the PID algorithm, which gives us an output between 0 and 2000. And then we use 2 delay functions. So let's just imagine for a moment that the PID spits out a number of 1000. So that's going to go here, digital write, relay pin, sets it high, and then we wait for 1000 milliseconds, so 1 second, and then we do a digital relay write low, so that switches off the heating elements for basically 2000 minus 1000, so 1000. So that would give us a 50% duty cycle. Obviously, if the output's 2000, it stays on all the time, and if the output's 0, well, higher than 0, you just get it on for a very short amount of time. And that's really it. So here I'm just testing the final thing. I've basically set the fan on 100% and my temperature set point to 100 degrees centigrade. Both switches are enabled, and you can see the temperature gradually rising up. What you'll see though is it actually starts to sort of flatten out around 80, 75, 80 degrees. That's way, way over damped. It's not even reaching the set point temperature. So that's not good enough. Perhaps most importantly, the dashboard, the ESP32 and everything seems to be working to some extent. So I think once I've tweaked those PI and D values, we're ready to start roasting some coffees. They don't look bad. So I have my beans, smashing into the grinder. Let's do a relatively fine setting. I'm going to get one shot at this. Okay, let's grind. Well, it smells like coffee. can see I've actually got a PID controller on this coffee machine. It's a home-built one. I built it during lockdown, so I didn't film anything, unfortunately. But anyway, let's see what happens. Let's go. So the resulting cappuccino looks not perfect. Not much crema there, but let's see what it tastes like. So, according to the package, it says incredibly smooth tasting Arabica Sidamo coffee beans with a cherry, blackcurrant, and a hint of mocha. Well, to be honest with you, all I taste is shit. But there you go. I'm afraid, oh dearie me, I won't be enjoying the rest of that, which is a shame because I don't like to waste all that effort and food, but not the best coffee I've ever tasted in my life. Oh, it doesn't even smell right. So I know you're meant to leave freshly roasted coffee for a few days after you've roasted it, so maybe that's where I went wrong. But certainly if anyone has any expertise and good ideas on tell me what I did wrong, please, I'm all ears. I'd love to know. Just to summarise this video, we used a cheap popcorn popper to roast some coffee beans. We actually did this using an ESP32 microcontroller, and we learnt how we can actually make a control loop using a PID algorithm. We also saw how we can use the Arduino IoT to make like a graphical user interface and actually be able to control the ESP32 from anywhere with an internet connection. And in the end, we even roasted some coffee beans, and the results need a lot of work. So if there's any coffee aficionados out there, leave a comment and tell me what I did wrong. I have some ideas and I'll work on trying to make the system better when I have a little bit more time. So that's it for this video, and there's actually several more videos similar in style, both long and short form, in the pipeline that are going to come out soon. And thanks again for all your likes, comments, and of course subscribes. Here's to that 1000 again. And please do, if you've got any comments or anything, questions, put them in the chat. Thanks for watching, and I'll see you in the next video. Cheers.